Hey everybody, Rick Bedeau here once again. It's Friday, you know what that means. That's right, welcome to another EAC Additive Fab Friday. Today I have something super cool to show you guys. If you've been watching all along here, geez, I don't even know what we're on now, what number, but we're up there, right? Fab Fridays, you'll recall the stainless steel print that we made a while back, and I kept promising that we're going to have a finished part here to show you. It came in, it's pretty cool, and I'm going to show you that, but we also have something else that's really cool, and I'll talk about that here in just a second. So let's see what we got here on the table. Get this out of the way here. All right, so what do we got? Let's take a look here. If you recall, this is what we had earlier. This is the what we called the green part. This is a part that was printed on the Minneapolis 310. You can, I don't know, you really can't tell that it's stainless steel. You can't feel how heavy it is, but this is pretty cool because it's really heavy. The thing about this is once you 3D print this, that's the green part. It's really not steel yet. It's actually pretty fragile. Somebody was dinking around with this, and actually you might be able to see a little crack here. They broke it, but I glued it together just so we can have it as one piece. But yeah, this is pretty fragile. You really don't want to do anything with it. You can possibly polish this, so you may not necessarily have to sinter it, but it's really not going to be a very strong part. So we did, as I promised, we got the sintering done. This is that part. Pretty cool. This is a sintered part, so I'm gonna maybe change the view here so you can kind of see this, so you can sort of see what happens when you sinter, right? Let's see here. How can I orient these two? Back up a little bit. There it is. So you can see that these two are a different size, right? So the sintered part is going to shrink a little bit. So you have to be able to compensate for that. I haven't measured these to see if it's shrunk to the correct dimension. I probably should check that. But you have the shrinkage that you have to put in this is not uniform. So it's different in the X and Y versus the Z. So I will get around to measuring that and see how we did. I did have also a calibration cube that I wanted them to print or to sinter for us, but that didn't work out. I think the infill on that was just not right. So, but we did get the putter back here, so that this is that putter, and you can see that it's metal. This is 3D printed metal. And then my weak attempt at polishing, I hit this on a sanding wheel that had an emery board. Didn't spend a whole lot of time on it, and then hit it with a polisher. There are people out there who have taken this to a level where you really can't tell that that's metal. You can also maybe see that I have a crack right here. This little crack. That crack, again, due to shrinkage, maybe the infill in that point, that spot wasn't too great. Plus we've got kind of a weird, going from thick material to thin here. So a number of factors could play into that. But yeah, that's pretty cool. Stainless steel printed part, printed on the Minneapolis 310, using the BASF Ultrafuse 316L filament. So definitely a cool application, and if you really absolutely have to have steel parts, don't let anybody fool you. It's not crazy hard to get stainless steel parts. So what else do I have to show you? Well, there's some other really cool things here. Let me get all these together and I'll tell you what happened here, what we did, what I tried here. So I had a customer interested in making polypropylene parts, and the fuse can print in polypropylene. What they wanted specifically was to be able to do spin welding. So I thought, you know what, let's give that a shot. I don't think that's going to be too complicated. So these are the parts. I just mocked up a couple of parts based on kind of their product mix. These are fictional parts. I just whipped these up in CAD. So this is the main part. It's a little I don't know what it is, whatever. It's a little vial or something. You can see we've got two ends here, that end and this end. I guess in my imagination, I was thinking this end would be like you know, where there would be a fitting attached to it, and this end would have a barb fitting with a, you know, hose or drain or whatever. I don't know, whatever. I'm no chemist, and like I said, I just made this up, so I have no idea if it's any kind of a real world thing. But the whole point of this was to make it so that I had an area where I could attach two components. So I mocked up this little guy here for the top one. So this has got a little thread on it. You can kind of see it. You can also see that it's a little grainy. The polypropylene is a little grainier than the nylon material. However, this has not been polished or anything. So I don't even know how much effort. I got this directly from Formlabs. I don't know how much effort those guys put into getting the powder off. So it wasn't polished or anything like that. So that's one fitting, and then this is the other fitting, a little hose barb here that you can kind of see when you're designing things for spin welding, you have to accommodate for the material that's going to basically weld to the other part. So you can see that little flange, that little lip there. As you turn it, it's going to melt and it's going to attach itself to this surface here. Likewise, this one also has, you can see that lip there, and also this piece here goes inside here like this, and I will try to put those together. Kind of goes like that. Yeah, so I mean, this is what you would do. You would take those two things here, and this is designed so that you could use a tool to spin it, because we want to spin weld this, so you're going to use a spin welding tool or a drill press or whatever. So I developed these little tools here to do that. This was printed on the Form 3 using durable material, and trying to do this with one hand. You can sort of see how this goes on to, let's see if I can line it up right. There it is. So you can see that those teeth, come on, there we go. You can kind of see that those teeth fit in there. You throw that in the chuck of whatever you're going to spin, and likewise you got this thing here, same thing. It's got a tool that I made for that as well. So pretty cool. All of this stuff 3D printed, of course. And so when I did this, I threw this in the chuck, held this with my hand, put that thing in there, turned the drill on for a few seconds, and that's what we got. So you can see, you might be able to see that there's some material in there, but yeah, that guy's welded. It's pretty phenomenal. That's pretty cool. And this one here, because I'm just I couldn't line it up right or whatever. Didn't turn out great, but it welded. It's not coming off. So, and those welds are going to be watertight. By the way, polypropylene, one of the few SLS materials that is watertight. Even though it's grainy like this, it is watertight. So perfect application for polypropylene. Pretty neat that you could do that. I was impressed. And I just did that with a drill. That wasn't anything special. I didn't use a special, there are special tools out there that are used for spin welding. That was just a drill. So it worked out pretty cool. But yeah, that's a couple of neat applications for additive manufacturing here. Spin welding, stainless steel. Neat stuff, right? We can do all that stuff. So be sure to contact us if you have any questions. EACadditive.com. By the way, a couple of little noteworthy things. Our e-store is now online, so if you're looking for material, definitely check it out. We've got all the Formlabs material and components that you need there. And also to check out our website for the AM Connect. Our next AM Connect coming up here in the end of the month will cover AR, so that's augmented reality, and AM, additive manufacturing, and how those two can work together. It's going to be pretty cool, really interesting demonstrations of AR especially. We already know that AM is cool. So anyway, from Minneapolis, have a great weekend, and we'll check you next Friday. Take care.